Next, we're going to do the same thing, only using a dynamic array, which is convenient because it's going to be the same as an array, only we don't have to manage our resizes. It will do it for us. But all of the analysis are the same, and the implementation details are largely the same until you get to how you actually do the implementation. But we're still going to be pushing by writing to the first free index and incrementing a variable. It's just that our dynamic array is going to do a lot of the heavy lifting for us. And we don't have to do our resize when we run out of space because Python is going to do the resize for us using a geometric growth. So resize operations become less common as the array grows. Okay. Under this paradigm, because we're using amortized analysis, each addition to the dynamic array is big O of 1. Now, when you do a resize, it ain't going to be big O of 1. It's going to be big O of n. But those resizes will get less and less and less common. So on average, each push is going to be a big O of 1 process. So all of our operations are going to be big O of 1. We still have the requirement for contiguous memory. There's no way around that. And like I said before, right, you want to create the array, if you're using a static array, to be too big when you start. So if you already know how big your array needs to be, like if you know that I'm only ever going to have a maximum of 100 elements in the stack, you should just create your array to be 100 elements at the beginning and be done. And you don't have to worry about resizes. So there's no reason to worry about using a dynamic array. But if you don't know, you can. You can absolutely use a dynamic array. And again, the code is available up on the Canvas page, right? So we've seen an array stack. Now we're going to use a list stack. And I'm going to pull the dynamic array up for a side-by-side. The static array up for a side-by-side. So we've got our dynamic array on the left and our static array on the right. Okay. So notice the difference in constructor. We can just create a new empty stack with a list. And it's going to expand when we need it to, so we don't have to set a default size. And we also don't need to store the length because our dynamic array is going to do that for us. Right? When we append now, we don't have to check for the size. And we don't have to add the length. We just append, right? That's what we're doing. When we push, we just call append. And that will write to the next available slot and increment our value. When we get to pop, we still have to call our peak, right? Grab whatever the next element is, right? And then we have to remove the top element from the stack and then return our stored value. Now I'm doing it this way. I'm explicitly calling DEL. Some of you are out there screaming, Professor, can't you just do this? And the answer is thanks, I hate it. You absolutely can call pop. I hate that that thing exists on the dynamic array. And here's why. Pop is almost I'm going to say exclusively associated with stacks. When you are learning especially, but even in general, these names matter, right? They don't matter to the computer. They matter to us as people. And by putting pop there, you're kind of confusing the paradigm. You're confusing people on what is this thing. So I really try not to use pop because pop always implies a stack, and this and data is not a stack, right? The stack is the stack. This is a dynamic array. So I try not to use that. If you used it, I would grind my teeth and I'd say it's fine. I don't like using pop with lists. Don't like doing it. Okay. We can then see our peak, right? Notice that I've got a lot less code, and we'll see why in a moment. Look at our peak. Our peak's identical because indexing is the same across static arrays or dynamic arrays. And our logic is no different. Okay. Our length is a little different, but it's only in the sense that hey, here we're storing the length in a variable. Here, we're not. Data is a dynamic array. So data will store the length in a variable for us, and it'll return it when we call this. So that makes life easy. And then we scroll down and hey, look, we've got a resize array method. We don't need that in our dynamic array. It will do it for us. So that's the difference. So this is the implementation details on our dynamic array. And forgive the noise in the background. And this is how we can work through it. But we still have this issue of contiguous memory. So let's look at our next option.